Hi guys, welcome to the 9.4 normal distributions video. In this video we're going to take a look at these types of data representation, and we're going to be able to analyze if it has a normal distribution or if it doesn't. So a normal distribution has a bell-shaped curve that shows how the data is distributed from the mean. So the mean, you can see here, is in the center, because the X with the line over the top of it means mean. And then each standard deviation, which is like a little, swoop that we had before in the other videos, is one standard deviation away from the mean. So if you're looking at the empirical rule, you have about blank percentage of data falls within one standard deviation from the mean. So one standard deviation away would be one to the left and one to the right. So all we do is we add 34 plus 34, and it would be approximately 68% will be one standard deviation away. Then the same thing for two standard deviations away. However, you're going to do the second away from it, then the one that's one away, and then to the right, and then to the left, one more to the right. So it's two away from each side. So if we add all four numbers together, that would be 13.5 plus 34 plus 34 plus another 13.5. That would equal 95%. So about 95% of the data for this bell graph will actually be falling between two standard deviations away from the mean. And then the last part would be three standard deviations away. So we're going to also include those 2.35 that's on the outside. And you'll notice that the 0.15% is not included. So we can shade all the way up to the 0.15%, but we're not including that, so that when you add everything together would be 2.35 plus our 13.5 plus our 34% on each side, and that would be 99.7% will fall within three standard deviations away from the mean. All right, so for this part we have to create a normal distribution. So you'll need to put your three notches on each side of the mean. And in the scenario, it says the amount of cereal in a carton is listed as 18 ounces. A machine fills the cartons, and the amount filled follows a normal distribution with a mean of 18 ounces and a standard deviation of 0.2 ounces. Label the distribution. So we put 18 in the middle because it tells us that the mean is 18 right here. And our standard deviation is going to be 0.2 away from the mean, to the left and to the right. So just like a number line, we're going to add 0.2 to 18 all the way to the end, and then you're going to subtract 0.2 from 18 to go to the left. So now that you have your normal distribution, we're going to identify the percentages of each area. So you want to draw lines going up to the bell, which is the bell curve, and connect the top two. That'll be 68% of your data. Then to those two lines will be 95% of the data, because that's two standard deviations away from the mean. And then three standard deviations away from the mean to the left and right will be 99.7%. All right, so for this section, you're going to use the bell graph that we already created from the previous problem. And we have to find the probability that a carton of cereal contains less than its listed amount. So if it contains less than the listed amount of 18 ounces, well, look at that bell graph. That's 50% of the bell graph, right? And then find the probability that a carton of cereal contains between 18 and 18.4 ounces. So that's this section. So that's 34% plus 13.5%. That would be 47.5%. And then find the probability that it's between 17.6 and 18.2. Well, 17.6 to 18.2 would have 13.5, 34, and 34% that we have to add together. 34 plus 34 is 68, and 68 plus 13.5 is 81.5%. All right, so for this part, we have to draw a bell curve. So it says the scores on a test given to all juniors in a school district are normally distributed between a mean of 74 and have a standard deviation of 8. So we have to find the probability that a randomly chosen junior has a score between 66 and 90. So you're going to make a bell curve down below. And we know that the center or the mean is 74, so we can label that. And they also told us our standard deviation is 8, so we're going to add 8 to the right. So that's 82, 90, 98, and you're going to subtract 8 for the left to make your number line, 66, 58, and 50. So now it says find the probability that a randomly chosen junior has a score between 66 and 90. So we make our lines to the top, and between 66 and 90 would be about here, between 66 and 90. So we're just going to add 34, 34, and 13.5 together, and you get 81.5%. So what that means is the probability of randomly picking a junior, their score has an 81.5% chance of being between 66 and 90 on this test. Go Seahawks! Woo!